Hey guys, Paul, Inventor3. Okay, just gonna go over some points real quick in this video. Um, now that I've revealed everything in my last video, I just want to make some more points and add to that. Let's start with real quick this schematic that I showed you guys. Now this correction here, just in case some of you guys didn't get it. Yeah, I have the negative down here, bridge rectifier is drawn correctly. Yeah, I actually have a video. It's you could see in the video probably too and confirm that. Okay, this correction, let me keep this video going here. These circled areas, see the plus side of each string here are all connected to each other. The negative ends, they'll all go to that point. Now the next string, the second string of LEDs down here, you can see right here it's going from the plus down here to the minus, the plus, minus, plus. And that's where I had my mistake. There's the back side. See, instead of connecting here to here, my mistake was it's connected on this end. This is still the same. The pluses are all connected to each other. Negatives are all going up to the point. But when the correction is when you go to the next string, it's not connected on this end. I have it connected on this end, and this one is connected on this end. This one's connected on this end. So we're still going minus the plus, the minus, the plus, the minus. So that's that correction there. I want to make sure everyone understood that. Okay, here's our schematic on what we have right now. Let's just clarify this too. I know someone asked about real schematics. Yeah, I could draw real schematics, but I just make it this way so that people can, people that are not electronically inclined or something, that cannot read schematics, understand. And I just didn't want to draw 10 little teeny tiny arrows with 10 little tiny arrows on top of it, and that's really hard to see. This is my 10 jumbo LEDs. Those things in my loop. You know, this is the capacitor. These are connections to my light bulb. No, this is not the proper schematic symbol for a light bulb, but at least we all understand that's a light bulb. So I just do it for simplicity's sake of drawing it, and also so of easy understanding. So, alright, let's see, I may pause this video once in a while, but just like my last video, hopefully it should all be unedited. Let's see, how did it all start? Okay, real quick, and again, I'll try to be quick about this stuff. You see this plate right here? This is a nice plate. My buddy, assistant Bob, let me use that plate for experiments and collectors. And here's my table. See, there's a bunch of plates down here too, aluminum, copper, and I had my primary coil and the other end of the primary coil, and I was watching a Don Smith's video, and I'm going to put the link to that video in this video description. At 46 minutes in, I believe it is, someone from the audience said something about a ground, and Don Smith went back up to his board and erased one line and said, yeah, you could have it go to ground. And that's when I came back to my experiment, and I connected the other end of that coil to a plate over here. All of a sudden I had a coil over here with some LEDs on it, and they all of a sudden lit up. And yeah, you know, I crapped my pants a little bit there. I was like, what the heck is going on? And then I realized that signal is going through there. It's up against the metal leg. The metal legs go up to bars that are under here, and it was picking up that frequency. And that kind of got the ball rolling for me. And then, when I came up with the idea of this asymmetrical plate, and I'm going to see if I could dig up some old photos of when I was making this plate here. I probably got some photos of it, and I'll put it at the end of this video. Yeah, it's hard to see. Let me take this off again. You can see there's just one center plate that's just flat, and then the receiving plate wraps around the other one with a plastic insulation in between. This plate here, this is just rust spots you see on there. This is just a mild low carbon 1018 cold rolled material. But yes, it works just as good with aluminum plate, copper plates, anything that's conductive. Now, let me tell you about that. The distance between these plates, I've experimented with many times, especially in these other versions. I really have not seen any difference in separating those plates with more distance, which is kind of odd. And of course, I don't have any instruments that could actually measure the capacitance of that. So, is it a capacitor? There's something magical about it, all right. I don't know. The other thing I wanted to mention about that is, one important thing about that is that's what makes this an open circuit. There's no physical connection between one plate and the other. So, when you have your source, okay, and there's a guy out there I want to thank, Byron MXX Maximus. Anyhow, he told me for a while about, Paul, you don't load the source. Don't load the source. I couldn't figure out how he meant or how you would do that. Okay, don't load the source. It sounds good, but how the heck do you do it? And I don't know, a year later or something, my experimentation here finally came to me. Well, and he would also say, well, no, he didn't say, yeah, don't load the source. Well, you have a transmitter and a receiver, and now the load is on the receiver end. See, that's where our loop is. That's where everything else is. So, is this really detecting a full load that we put over here and all these lights? Is that detecting it? I think all this thing is really seeing is one flat plate that's in the middle. That's not connected to anything. This plate is not connected to anything. It ends right there. It's a dead end. I mean, there might be some resistance. There is a coil on there too, so there's some resistance probably in there. So, there's not much of a load. And that's why I keep telling you guys, I'm not drawing, even though this could allow you to draw a maximum of 100 milliamps, I'm not. So anyhow, let's see, I'm covering a lot of stuff quick. I'm skipping through a lot of my notes. Well, that's good anyhow. One thing I've noticed through experimentation, I've learned, and it's pretty cool, and I'm sure textbooks tells you about it somewhere, some way, but now this coil was my first primary, and then I switched to this one. I could even use this one. If you had the same length of wire, and it is the same diameter, this is the same length and diameter wire, this is the same length and diameter wire, this is the same length and diameter of wire, and they all measure about 0.25 millihenries to 6, all of them. So it doesn't matter how big of a core or what, or less windings, more windings, because I always wanted to stick, no matter what coil you start with here, whatever frequency you want to go with, you want to make sure your other coils, well, to make things easy again, and probably to get the most power transfer is to make all your coils in harmonics of that. Now this coil, coincidentally, is the exact same length wire, same wavelength as all these, but now we changed the diameter. Now this little guy, well, it takes up a lot less space. I have had a heck of a field radiating off these things too. But this guy now, instead of being 0.25, it's about 5 times as much induction. Like I said, it's not really about... See, this one has many times more windings than that one. But these still have the same amount of induction. Same amount of henries. But this guy, it's not about the number of windings, about the diameter. So that was interesting. That's like 1.2 something millihenries. Anyhow, okay, let me see. What else was I going to talk about? Hang on, let me pause for 1 second. At one time, you know, I did see one video of Don Smith where he showed this white capacitor. It was about, I want to say about 3 or 4 inches square. It was only maybe a ½ inch thick or something. He had it special made by this one well-known capacitor company. And I couldn't help but to think that maybe that's the one thing he's hiding from everyone. He said what was special. I think it was made for like either 15 or 35,000 volts, but that's all he mentioned. I couldn't help to think to myself, what if he's got a plate in there with another plate around it, and it still could be, with the right dielectric and spacing, it could still be made to handle that much voltage. But maybe there was something more to that capacitor he wasn't telling us about. That would be something he would be able to put right in front of your face, and you wouldn't see it or know about it. Oh, it's just a capacitor. Anyhow, okay, let me look at my notes again real quick. Alright, another thing. Yeah, there's a video I got out there with this one. Let's see, I had this one, like where this one's at. And then I had like 4 of these under it, and each one was lighting a bulb. I remember I kept doing this all different ways. I've had a loop here, and then I had an identical loop with the same coil, and that coil had to be a certain distance from this one, and I would get 2 light bulbs lit. Same energy. They're not quite as bright though, I will admit that. But there was a certain distance, but it was cool, because again, I'm having one loop, and the other loop was picking up from that first loop, you know, a whole nother identical loop. There were so many different ways I did it with not just coils. I had one video talking about replace the coil with the foil, because then you don't have to, it's not as important to get everything resonating or to be in a harmonic. It's just a plate. It can pick up the energy. Now, at one point I told myself, what are you doing, Paul? You keep going wireless to wireless to wireless. I said, you already have wireless. It's already wireless. You know, so I keep going right back to just feeding off this little loop. And even if you just have one string of diodes or LEDs right here, if it just went here, LEDs and back, that would probably work too. What I'm saying, that's still a loop. Let's see, what is the other point I'm going to make? Hang on. Oh, so I just wanted to talk about that for a second. What is this energy in this loop? You know, I actually thought about this when I first learned electronics. I was like, what if you don't have a return? What if you don't have a ground? What if you just have the energy go in and go in a loop. Yeah, little I know, there was something to that. What is this energy? Is it just an electrostatic buildup? Like walking across a carpet and touching a doorknob? How can I get so many LEDs and so many things working? You know, it also makes me think of the analogy that got of like pushing a ball, tapping it uphill. That also makes me think of non-Newtonian fluid, basically cornstarch and water on a speaker, and that speaker, that frequency hits it, and before it gets a chance to come all the way back down, it's smacked again. It goes higher, smacked again, goes higher. So that's kind of like tapping that ball, boom, 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 hitting that ball uphill, building up a lot of energy, and that's like Tesla and a resonance and like pushing someone on a swing. You could build up a ton of energy with just a little tap of a finger. But then if you jump in front of that swing and have enough energy to knock you over. So it kind of makes me think of this too, is that another thing that's kind of happened where, because this is a pulse DC and we're pumping and it's got like nowhere to go. It can't come back out. And it's just pumping up all this energy. Yeah, I don't know. So it's just, something to think about too. But whether it is or whether it is not, whether it's all, I'm sure it's all scientifically explainable. Everything is. The thing is, this could be a system that could be utilized. I thought about a string of Christmas lights, and I'll tell you guys that too. Geez, I've had setups where it's just one string of LEDs and the end could be going into earth ground. Take a little rod, go put all these lights across your bushes. It doesn't matter if your LEDs are facing, the string is facing this way, or you could turn around and face it that way. It still works. What? It doesn't matter if a bunch of them burn out. The other ones still work. What? $1 million idea, right? You know what? I got a video of that too, and I'm going to put that in my video link below this video too. I'll put a link in there. It doesn't show Christmas lights. It shows a string of LEDs and how I could blow some out and how the other ones still on both sides of that LEDs keep working. All right, let me check my notes again. Let's see. Oh, real quick. I know another one. I know I had a lot of wires hanging here. Here's another AV plug that I have. It's just two. Let me pick that sucker up here. Oh, there we go. Diodes up there. 2 diodes. Just loops around. Goes to an LED. And as you see, this black wire just goes to earth ground. This wire is just hanging here. It's just near the plates. Like I said, these plates are very active. Now, what about placing, 10,000 AV plugs and lights right on top of this? You can. What do you think I was thinking when I had this thing? You know how many AV plugs and things you can put on top of there? Just like I said, there's so many different ways I've had this set up, guys. It makes my head spin. Let me check my notes. We're almost at 20 minutes, 19 minutes. Hang on one second. Maybe we need to experiment with a larger loop. Does that loop have anything to do with it? I want to try a very large loop made out of like copper tubing, like my primary coil on my Tesla coil over there, because that would give us a ton of surface area. But then we also have, I don't know if there's some type of effect that would be a negative effect because of the ID. I'm not sure. I don't think so. I think it would just give us more energy, more surface to ride on, as long as we're in a high frequency. Let's see. What else? What else? Hang on one second. Oh, I know somebody asked, what were the, where the heck are those little coils? Oh, I got this upside down. About what these little coils were here. And you can go back to my videos too. They're those right there. I forgot how many. That's this one. This should be this many. 49 feet 2 inches. That's what I have the length on there, and that's about 5 thousandths diameter. Okay, you can forget about the turns and all the other information on there, but that's the length of that one. Okay, and let's see, what else? Looking at my notes. Let me disconnect these LEDs that I had over here. Alright, what do we got right now? Oh, we got to change the frequency big time, don't we? Hang on, I'll be right back. There we go. Let's see, 134. As the capacitor charges, I have to adjust the frequency slightly. 169, 170. Give me one more second. Let me see where I can get that to. Hang on. Alright, anyhow, I'm at 178 volts right now. I think my last video I had 180 something. Across that capacitor. It's rated at 450 volts, I think it is. 25 microfarads. Not much capacitance. But now this is the importance of those plates. Let's see. Let's just... If I put... Did you see what I just did? I knocked that block down just to bring one end of my plate lower. You can see the voltage is dropping right away. Now I have to readjust my frequency. It's a lower frequency now. It's a little better, see? So that's what you have to play around with, and that's why I like this plate, because it makes things very simple. Scan through those frequencies, get the best voltage, raise or lower the plate a little bit, scan through them again, and keep doing that over and over again to get the best results. Let me think. Oh, I still want to try ignition coil in there somehow. That would be cool. I know Dr. Stifler always used AC as far as I know. I'm always using a pulsed DC. If in any time, any of my experiments, I've tried AC many times, never ever have I gotten as good results as I do with a pulse DC. Pump up that energy. I know one person asked me about this hanging active wire. Actually, I have video part 24, good visual of this setup. I think you could even see the rectifier in there. Maybe you could pause the video and check and make sure I do have it correct. I think I do. It shows the hanging wire and how I add bulbs and everything to it. And I'm going to put some other links in the video below too. I think that about wraps it up, doesn't it? Oh yeah, my hairpin circuit. You guys should go back and watch that one too. There's some good videos on that. That's with the safe electricity, putting my hands on a lit bulb underwater. Lighting bulbs, sending the energy through the ground, all this stuff. Okay. Alright, I think I covered it all. Jeez. Woo. Alright, that was a lot of extra details. I hope you guys had out a... That's the first thing I meant to tell you again. Pull out the pen and paper, and hope you guys know what you want to ask. Oh my gosh. A little tiny table. I think I'm on book number 6 or 7 notebooks of this project alone. Oh my god. Alright guys, we'll see you again real soon. I want to see some good ideas out there. Ask questions. Don't be afraid to ask any questions. No such thing as a stupid question. Give me your ideas, things to try. Alright guys, see you guys soon.